While much of the world is sliding deeper into a global water crisis, the Middle East has become one of its most visible pressure points. Rivers that once supported civilizations are shrinking, underground aquifers are collapsing, and entire regions are facing the possibility of mass displacement due to water scarcity. In parts of Iran, officials have warned that water shortages could eventually force people to abandon major cities. Iraq's historic rivers now carry only a fraction of their former flow. Across Syria, Jordan, and Turkey, farmland is drying into dust. Yet in the middle of this regional crisis, one country stands out for an unexpected reason. Israel, despite being largely desert, now produces more water than it consumes. On paper, this should not be possible. Roughly 60% of Israel's land is classified as desert or semi-arid. Annual rainfall varies dramatically, from over a meter in the far north to barely a few centimeters in the south. Natural freshwater resources are limited, and the country has no major rivers comparable to the Nile or Euphrates. And yet, Israel today generates around 20% more water than it needs in an average year. This transformation did not happen by accident. It is the result of two massive engineering efforts, built 6 decades apart, that fundamentally rewrote how a nation sources, moves, and reuses water. A country with one lake and a growing population. To understand how extraordinary this shift is, it helps to return to the 1950s. At that time, Israel was a young state experiencing rapid population growth. Agriculture was expanding, cities were spreading, and water was a matter of national survival. The problem was geography. Israel had only one major natural freshwater reservoir, Sea of Galilee, also known as Lake Kinneret. Nearly everything else lay south of it in the Negev desert, where summer temperatures soared and rain could vanish for weeks at a time. Groundwater was limited, unreliable, and vulnerable to over-extraction. The question facing the country was stark: how do you sustain a modern nation when most of your land has almost no water at all? Building a river that never existed. The answer was radical. Israel would build an artificial river, an enormous national water network designed to move fresh water from the north to the desert south. This project became known as the National Water Carrier. Stretching roughly 130 kilometers, it would take water from the Sea of Galilee, located more than 200 meters below sea level, and deliver it to regions hundreds of meters higher in elevation. Construction took 5 years, cost hundreds of millions of dollars, and required more than 4,000 workers. From the start, the project faced a brutal enemy: gravity. Water entering the system sat deep below sea level, while the national distribution network it had to feed into lay well above it. The vertical lift required was roughly 257 meters, an enormous challenge for mid-20th century engineering. To solve this, engineers built a massive underground pumping station, carved directly into a mountainside above the lake. Water entered through an underwater pipeline, passed into a shoreline reservoir, then dropped down a vertical shaft into a hidden pump hall. Inside, towering pumps, each powered by motors producing tens of thousands of horsepower, forced the water upward in a single stage. Once lifted, the flow entered steel pressure pipes that merged into a main pipeline, capable of carrying millions of cubic meters of water every day. From there, gravity finally took over, pulling the water south through canals and buried pipelines toward arid regions that had never known reliable freshwater. Engineering precision at national scale. Transporting the water was only half the challenge. The pipeline system crossed farmland, rock formations, and unstable soils. Every section had to be surveyed with extreme precision. A small miscalculation could rupture the line or halt the entire system. Against the odds, it worked. By the early 1990s, the National Water Carrier supplied roughly half of Israel's drinking water. Initially, most of that water went to agriculture, but over time, the balance shifted towards cities as desert regions developed and urban populations grew. For more than 40 years, this artificial river functioned as Israel's lifeline. But success created a new problem. When one lifeline was no longer enough, By the early 2000s, Israel's population had tripled. Water demand surged. At the same time, repeated droughts pushed the Sea of Galilee dangerously close to its ecological limits. Pumping continued to fall toward the lake's black line, the level below which permanent environmental damage could occur. Relying on natural fresh water alone was no longer sustainable. In 2002, the government made a decision that would redefine the country's water strategy. Israel would turn to the Mediterranean Sea itself, turning the sea into a tap. The plan was ambitious. A chain of massive desalination plants would be built along the coast, converting seawater into drinking water at national scale. Construction moved quickly. Within a decade, multiple large facilities came online, each capable of producing hundreds of millions of cubic meters of fresh water per year. By the mid-2000s, desalination already supplied more than a third of Israel's municipal water needs. Today, it provides roughly 70 to 80% of the country's drinking water. The newest generation of plants pushed this even further. The latest facility alone added hundreds of millions of cubic meters of annual capacity and did so at one of the lowest per-unit costs ever achieved for large-scale desalination. How modern desalination actually works. What makes these plants viable is not just scale, but efficiency. Instead of pulling seawater directly through open intake pipes, many facilities draw water through subsurface wells drilled beneath the seabed. Sand and rock act as natural filters, removing debris before the water even enters the system. Inside the plant, the water passes through ultrafine membranes that remove algae, bacteria, and sediment. Then comes reverse osmosis, the core process of desalination. High-pressure pumps force seawater through membranes with pores so small they block salt ions, heavy metals, and dissolved chemicals. The result is nearly pure water. So pure, in fact, that minerals must be added back to stabilize it for human use. The water is then disinfected and carefully balanced before entering the national network. At full capacity, a single modern plant can produce enough drinking water for millions of people every day, relieving pressure on nature. As desalination expanded, Israel was able to dramatically reduce withdrawals from its natural water sources. Pumping from the Sea of Galilee fell by more than 90% over 2 decades. Aquifers were given time to recover. But Israel did not stop at making new water. It focused just as aggressively on using water more than once. The world's most advanced water recycling system. Today, Israel treats and reuses more wastewater than any other country. Nearly all sewage is collected, treated, and redirected, mostly for agriculture. The majority of irrigation water no longer comes from fresh water at all, but from recycled effluent. This closed-loop approach means that almost every drop of water performs multiple jobs before leaving the system. Drinking water becomes wastewater, which becomes irrigation, which supports food production in regions that were once barren, reversing the flow of a national river. By 2020, Israel faced an unusual situation. Desalination plants were producing more water than the country needed in a typical year. That raised an unprecedented question. What if excess desalinated water could be pumped back into the Sea of Galilee itself, turning the lake into a strategic freshwater reserve? No country had ever attempted this at national scale. Engineers rebuilt sections of the national water carrier to allow bidirectional flow. New pipelines connected coastal desalination plants to inland systems. Pumping stations designed for downhill flow were upgraded to push water uphill instead. Advanced control centers were installed to monitor pressure, quality, and flow in real time. In late 2023, the system went live. For the first time, water that began in the Mediterranean Sea flowed inland and into Israel's primary natural lake. A circular water economy. Today, Israel operates one of the most integrated water systems on Earth. Seawater becomes drinking water. Cities and farms use it. Wastewater is captured, treated, and reused. Surplus water is stored in natural reservoirs for future droughts or regional cooperation. In just 6 decades, Regions that were nearly uninhabitable now produce the majority of the country's fruit and vegetable exports. When engineering changes the rules. In 1959, Israel faced what seemed like an impossible challenge: how to build a nation in a desert with almost no water. By 1964, it had constructed a river that never existed. By 2025, it had turned the sea itself into a reliable water source. Sometimes engineering doesn't just solve a problem, it rewrites the constraints entirely. The question now is not whether water scarcity can be overcome, but whether other regions will choose to build systems bold enough to do it. Water scarcity is shaping the future of entire nations, and Israel's story proves that engineering, planning, and long-term thinking can change what once seemed impossible. If you enjoyed this deep dive into how megaprojects quietly reshape the world around us, make sure you stick with the channel.